Hi everyone. So we're just gonna do a little bit of a recap on mixtures. So this is stuff that you learned in secondary 1 and in secondary 2. So this shouldn't be anything new, but this refresher. So the first thing, and this you learned last year in secondary 2, is the difference between an atom and a molecule. So when we're talking about an atom, it's the smallest particle of matter. And again, we have 114 different elements. So elements are a specific type of atom. And so if I'm looking at this, I have two different atoms here. I have a hydrogen atom and an oxygen atom. So both of these are different elements. Whereas a molecule are two or more atoms that are chemically combined. So if I have, for instance, water, H2O is a molecule that is made up of two hydrogens and one oxygen, right? So I can have this right here. So H2O is a molecule of water. I have this molecule, which is oxygen gas, O2, which is made up of two oxygen atoms. And then I have glucose, which is C6H12O6, which is made up of 6 carbons. So the black circles are carbons, made up of 12 hydrogens and 6 oxygens. Now, the next thing that we're going to recap is the difference between a heterogeneous and a homogeneous mixture. Now, the first thing that we need to realize is that mixtures are not chemically combined. And that mixtures can be separated, unlike molecules, which are chemically combined. So a heterogeneous mixture, I can actually see the different components with your eyes. So for instance, if we're looking at this piece of granite, I can actually see the different minerals that form granite. So biotite, quartz, and feldspar are just a few. Whereas a homogeneous mixture is you cannot distinguish the different components when looking at your eyes, and it looks like a pure substance. So a colloid is actually a specific type of homogeneous mixture, but you can see the components underneath a microscope. So for instance, milk is a homogeneous mixture, but it is also considered a colloid, because if I look at milk underneath a microscope, I can actually see the fat droplets. Whereas a solution, again, is a type of homogeneous mixture, but I cannot tell the components apart even if I'm looking at it underneath a microscope, because one substance has dissolved in another substance. So an example like this would be like apple juice. I know that I have sugar that is dissolved, but just by looking at it, I would not be able to distinguish it. Now, if we're looking at solution terminology, we actually have two key terms that we need to remember. That the solute is the substance that is being dissolved. Now, normally it's usually a solid, but it could also be a liquid or a gas. It doesn't matter, but it's a substance that is being dissolved, and it's a substance that you have less of. Whereas the solvent is the substance that is doing the dissolving, and it's the substance that you have more of in your solution. So if I'm looking at this right here, this would be my solute, right? This would be my solvent, because my solute, it's what I have less of, and it's what's going into my solvent, what I have more of. And just going to erase this. When I mix the two together, I get my solution. So my mixture of my solvent, which in this case is water, and my solute, which in this case is NaCl or also known as table salt. And when I have both of them together, I have my solution. Now, we can also define some other terms when we're talking about solution, and that would be the term aqueous solution. So an aqueous solution is anything where the solvent is water. And in most biochemical systems, the solutions are always going to be aqueous solutions because our solute is always usually going to be dissolved in water. And the next term is the concept of solubility. And solubility has to do with how much solute can be dissolved in a certain amount of solvent. So there always comes to a point where you cannot dissolve anything more, and that's basically the limit of solubility. Now, solubility is dependent on temperature. So usually when the solvent is cold, it could dissolve less materials than when the solvent is hot. And it also depends on the type of solvent. So water will be able to dissolve up to a certain amount compared to ethanol, compared to isopropanol, and so on and so forth. So we can end our little recap of mixtures by this quaint little comic where I have my water, which is my solvent, which I have my sugared powder, so my powder, which is my solute, and both of them together form my solution. Thanks for watching.